In this video, I will share how to derive an expression for electric potential energy of a system of a number of point charges. First of all, let us understand what is the meaning of electric potential energy. Suppose there is a system of any shape having a number of point charges inside the system. Question is, what is the meaning of electric potential energy of the system? Some charges may be positive, some charges may be negative. So there will be force of attraction and force of repulsion between various point charges. Due to these Coulomb forces, some energy will be created in the system. This energy created in the system due to Coulomb force between the point charges is called electric potential energy. This is the qualitative definition of electric potential energy. Now, what is the quantitative definition? Quantitative definition means suppose we have these charges 1, 2, 3, 4, 5, 6 and 7. Let's take this example. How to calculate potential energy of this system? What we do, the procedure is you take all the charges to infinity and mark their positions like this. Now we shall move all the charges one by one from infinity towards its position. For example, this charge number 1 is moved from infinity to its position, this one. Similarly, next we shall move second charge to its position, then third and so on. Then we shall calculate total work done. Suppose work done in moving the first charge is W1 and W2 is work done in moving second charge, W3 is work done in moving third and so on. If we go on adding these, we shall get total work done. So this total work done is nothing but equal to electric potential energy of the whole system. So this is the quantitative definition and the procedure how to find an expression for electric potential energy of a system of a given number of point charges. Now, in order to have more explanation about this, let me take an example of a system having 3 point charges. Let me suppose that point A, point B and point C arbitrarily represent the locations of 3 point charges. Suppose at point A charge is Q1, at point B charge is Q2 and at point C charge is Q3. Let's take this example. Question is, what is the potential energy of this system of 3 charges? As I explained earlier, the procedure is you move all the 3 point charges to infinity and mark their locations. Now the procedure is you move first of all this charge Q1 from infinity to point A. When this charge Q1 is moved from infinity to this location, there is no other charge in this area. So this charge will experience no Coulomb force. That means no Coulomb force means no work will be done in moving this charge Q1. So I can write work done in moving the first charge from infinity to its location A is equal to 0. Now the second step is, now we shall move charge Q2 from infinity to its location B. Now when we are moving this test charge, then Q1 is already present there. So this charge will exert Coulomb force on this test charge Q2 and some work will have to be done. So we are to calculate work W2. Now how to find work? We multiply test charge with electric potential at point B due to source charge. Why I have written this relation? Because definition of potential says work in moving the test charge from infinity to the point divided by test charge. Using this idea, I have written this formula. Test charge in this case is Q2, and what is source charge? Source charge is Q1. So I can write value of potential at B due to this source charge as equal to 1 over 4 pi epsilon naught Q1 upon R. R, what is R? R is distance of point of observation from the source charge. Let me suppose this distance is R12, means distance between Q1 and Q2. So I can write this. So this is work done in moving second charge. Let me call it equation number 1. This was work done in moving first charge. Now the next question is, what will be work done in moving the third charge from infinity to its location C? When this charge is moved from infinity to location C, now it will experience Coulomb force due to Q1 as well as Coulomb force due to Q2. So two types of forces will be experienced by this. So work done in moving charge Q3 can be splitted into two parts. Work done in moving third charge against first, and work will also be done against the Coulomb force due to second charge. Let me call this W31 and this as W3T. Now we have to calculate these two values as earlier done. Work done in moving the test charge Q3 against Coulomb force due to Q1. It is denoted by W31. It will be equal to test charge multiply by electric potential at point C due to charge Q1. So W31 can be written as Q3 multiply 1 upon 4 pi epsilon naught. Now potential is due to this, so source charge will be Q1 and over R means distance of point of observation from the source charge. Now in this case, let me suppose this distance is R13. It will be R13. Similarly, we can calculate work done in moving third charge against Coulomb force due to second charge, that is W32. In this case again we shall multiply test charge which is being moved with potential at point C due to this source charge. It will be 1 upon 4 pi epsilon naught. Source charge is Q2 divided by the distance of point of observation from the source charge. In this case, distance, let me suppose it is equal to R23. So we have got both these works. So total work done in moving this third charge can be written as W3 is equal to W31 plus W32. We shall add these answers, and so we can write W3 is equal to 1 upon 4 pi epsilon naught into Q1 Q3 upon R13 from this equation plus Q2 Q3 divided by R23. Again let me repeat, R13 means distance between first charge and third charge. R23 means distance between Q2 and Q3. So we have got work done in moving all the three charges one by one from infinity to their locations inside the system. Now we have to add these works and get total work done in moving all the charges. It will give us total electric potential energy of the system. Thus, total work done in moving all the three charges inside the system, W equal to W1 plus W2 plus W3. By putting the values of all these three, we can obtain W equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R12 plus Q1 Q3 upon R13 plus Q2 Q3 upon R23. This is the total work done. So this total work done, as I have earlier explained, gives us total potential energy of this system of 3-point charges. If I denote total potential energy by capital letter U, so we can write U equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R12 plus Q1 Q3 upon R13 plus Q2 Q3 upon R23. So this is the required expression for electric potential energy of a system of 3-point charges. That's all.